Where I come from is teaching and learning, English language in general. But I'm very interested in the uses of corpus linguistics in this context, and that's what I want to talk about today. There are lots of different ways, lots of different things you can do with corpora, language teaching and learning. The thing which particularly interests me is what's been called data-driven learning. Basically, using the tools and techniques of corpus linguistics for teaching, learning, using foreign second or other language. Okay? The term data-driven learning comes from Tim Johns, who coined it first in 1990, and he called this approach radical and revolutionary, which it can be. And corpus linguistics is not necessarily something which is very intuitive to everybody the first time you come across it. But really, when we get learners looking at corpus data, what we want them to do is to just take a bit of initiative to work things out for themselves by looking at language and seeing how it works, which is not a million miles away from what most of us are trying to do anyway in language teaching. Underpinnings, theoretically, lots of these theories and the names here will be familiar to you: idiom principle, Sinclair, chunking, norms and exploitations, Patrick Hanks, and so on and so forth. There are lots of good reasons to think that getting learners to explore language corresponds to our theories of what language is and how language is learnt, stored, produced, etc. The essential part in learning a language is you need contact with the language. You need exposure. Without exposure, you won't learn. But you need a lot of exposure to learn. Zahar and colleagues calculated that if their students, with the rate of uptake from incidentally from reading, if they read for an hour a week, it would take them 29 years to learn 2,000 words incidentally. So just by natural exposure, it's not necessarily very efficient. But that's where teachers come in, or possibly a corpus might come in. A corpus is a way of providing lots of exposure to language, but in a way that's focused and organised, that draws attention to particular features. Pedagogically, it's connected to all kinds of buzzwords in the field, things like authenticity and autonomy and discovery learning and induction and individualisation and lifelong learning and all these things here which are crucial in language teaching pedagogy today. But I won't talk much more about that. It's not the theory so much I'm interested in today. What I am interested in is the research that's been conducted in this area. So it sounds good. Well, I think it sounds good. I hope it sounds good to you as well, using corpus tools and techniques in language learning. But what does research have to say about it? In any area of applied linguistics, it can be quite difficult to make sense of research. You read a primary study, and it's a primary study. Then you read another primary study doing a similar kind of thing, and it gets not quite the same results, or it's in a different context, and are they compatible, or sometimes they have completely conflicting results. And there are all kinds of problems in trusting primary research. If you've heard of the papers by Yanadis in 2005, quite revealing, even in stringent fields like medicine, which is where they can't really afford to get things wrong, but they do. So to make sense of primary studies, how do you go about it? Well, most primary studies have a literature review in the introduction, which is a way of trying to make sense of previous research. But that's not really very reliable either, because if you're writing a primary study and you have your literature review, you're selecting a few papers which you think are interesting and which go along with what you want to say, or else they're occasionally ones you want to destroy. So you can't, there's a lot of subjectivity in the introduction literature reviews. Position papers, the same thing could be said, although position papers normally are written by people who are long-term experts in the field and who probably know what they're talking about, but they're still individual people and they still have their own personal biases and prejudices. Or you can try to do something a bit more rigorous, and this is where we get into the field of research synthesis as a whole. Research synthesis is a huge field in medicine and psychology. It's relatively new in applied linguistics, although there are papers by Krashen, for example, going back even to the 70s. It's particularly associated with work by Norris and Ortega, John Norris and Lourdes Ortega. Their 100-page meta-analysis in the journal Language Learning in the year 2000. And lots of other work they've done since then as well, to the extent that you get somebody like Luc Plonsky today, who's in applied linguistics, and the object of his research, as they would say in France, is research synthesis. He's not a specialist in cognitive approaches or this, that, and the other. His specialisation is research synthesis. He does research synthesis, he comments on research syntheses. So it's almost becoming a field in itself. The field of research synthesis, divides into two main parts, meta-analysis or narrative synthesis. Each has its strengths and its weaknesses. A meta-analysis, which is really what I'm going to be talking about today. Oh, it's gone back to the wrong mode. What happened? Oh, it's gone again.
That's all right.
You press the, be careful not to press the...
Stop. No, I'm pressing the right way then. No, it just goes. Anyway, meta-analysis. I should continue pretending all is well. A meta-analysis, what a meta-analysis does is it tries to take the quantitative data, only the quantitative data, so it can't look at all studies. If you have a qualitative study, a meta-analysis can't deal with it. So it can't look at all the studies in the field, only the ones with quantitative data. Okay? But because it only looks at quantitative data, it tries to be more objective than some other fields. A narrative synthesis can look at more papers because it can also include qualitative papers. That's its strength, but it doesn't have such a reliable way of looking at interpreting the data that it comes across. It has the advantages and the weaknesses of still having a large element of subjective interpretation on the part of the synthesis. In a meta-analysis, you tend to be interested in the product, what's learnt. In a narrative synthesis, you can look at the processes involved in learning. So differences, I'm not saying one is better than the other, but they're different things. A meta-analysis tends to be more ethic, looking at specific outcomes on items taught. Does learning happen? A narrative synthesis can be more emic. It can look at changes in attitudes and behaviours, the way people think about a language, and how we go about using it.
I should click use the mouse.
Yeah. So, meta-analysis, this is what I've been trying to do with Tom Cogg in Canada. We did a preliminary meta-analysis which is out approximately now in the Cambridge Handbook of Corpus Linguistics. But it really was a preliminary meta-analysis. I wouldn't recommend you read that and pay too much attention to it. We are now doing a full meta-analysis and we're getting slightly different results. So this is what I want to be talking about today. There are three main questions we wanted to answer with this meta-analysis. The first question is, how much research is there in this area? Data-driven learning using the tools and techniques of corpus linguistics in language learning and teaching. Second question, does it work? And the third question, under what conditions? What are the variables involved? I do have to say that this is work in progress. I haven't got quite as far as we had hoped before this time I submitted the proposal, so I can't answer all the questions yet, but we're getting there. So, first question, how much research is there? This is not an easy question to answer. And you commonly read people saying things like there isn't much. If you read this paper by Marr, there's a slant towards a speculative rather than evaluative end, observation-based rather than empirically studied. That was Marr's appreciation of data-driven learning. But it's back in 1993, so maybe since then there has been more research. So it's a bit worrying to still read 2011, 12, 13, 15, lack of empirical evidence, very few empirical research studies, more talked about than tested, still under research and still little empirical evidence. This is a field which is 20 plus years old, and people are still saying there's not much empirical research. And in a field connected to corpus linguistics, if there's no empirical research, that's a bit worrying. So the first stage is to try to locate all the empirical research in the field, systematically, not just by what you happen to come across serendipitously, but systematically. So methodological, rigorous, and exhaustive as possible. So for our definition, using the tools and techniques of corpus linguistics for language teaching, learning, or use, a broad definition to try to make sure we include as much as possible. But the broader your definition, the more variation and variety you're going to have within that. And this is the apples and oranges problem. You can't compare two things which are incomparable. So we are going to have to use a random effects model to try to connect all the data together. We would expect variation within this. The main literature, journal, papers, book chapters, books, but we also wanted some fugitive or grey literature, especially in the form of conference proceedings and PhDs, which are often not included in meta-analyses, but we think they were important. Up to including June 2014, so it's not completely up to the present day, but that's as far as we can take it at the time. In English, Not because we think English research in English is better, but just because, well, we happen to know French, but that's happen to know. And it would mean doing 2 sets of trawls even to get a second language. So we thought if we do 1 set of trawls with 1 set of keywords, it's more likely to be rigorous. So the trawling, the keywords we use with data-driven DDL, John's, the founder, corpus, corpora, and with a couple of limiting variables, limiting keywords as well, such as language and learning. So looking through the major databases, Linguistics and Language Theory Abstract, MLA, ProQuest for PhDs, Eric JSTOR, Directory of Online Academic Journals, and Google Scholar, which surprisingly brought up quite a few which we hadn't come across before. Reference sections, any paper we identified, we then looked at the bibliographies of those papers and followed up further references. Any source which provided 2 or more references, we followed those up by checking their websites from journals, publishers and conference series. So, in the preliminary meta-analysis, I had, I think, 130 something studies, and I thought that I was a bit of an expert in this field and I knew everything. 130 is quite a lot. This time, with this more rigorous collection, we got 205. So it's about 50% more that I'd never heard of, I didn't know existed. So if you think you know all the research in your field, probably you don't unless you've been systematic in trying to collect it. Of those 205 publications, we excluded some. Sometimes the same study was reported in 2 papers. A bit of it was in French. Some of it didn't have appropriate data, wasn't quantifiable. Looked at questions which weren't connected precisely to ours. So 64 papers which we could include in that analysis, a total of 88 unique samples, because in some studies they will have 2 experimental groups, which are completely separate. So it's like having 2 studies in one. It's not the control experimental group, the control doesn't count, but 2 experimental groups, or 3 or 4 experimental groups. You might have high levels and low levels doing chemistry learning, for example. And that's what it looks like. The years on the bottom axis, the number of studies. The black bars are the publications, red bars the number of studies, and the green bars are the unique samples, which we can include in that analysis. So as you would expect, very little empirical research in early days, but a fairly even curve going upwards towards from the late 1990s onwards. 2013, a bit less, perhaps because some things haven't been signaled to databases yet. In 2014, it was only the first 6 months of 2014 anyway. The question is that a lot? There's no answer to that question really. How long is a piece of string? How big is a corpus? It's a lot for some people, it's not a lot for other people. If it was a cancer treatment, you probably think it wasn't very much. But to me it feels like quite a lot. But that's a subjective interpretation. If you're interested, those are the studies, the 64 studies which we included. You'll see that sometimes there are 2 references because we had the same basic data reported in 2 studies. Okay, moving on to the second question. Does it work? Tricky. The reason I wanted to look at this was because in 2012 I had a chapter in a book co-edited by Shirley Carter-Thomas and Liz Rodriguez-Olivet, published by John Benjamins, and my chapter was called Corpus Consultation in ESP, a Review of Empirical Research. Looked at 20 studies, empirical studies of DDL in ESP. The book was reviewed in several places, and 2 reviewers had very similar comments. The studies differ widely, the studies differ widely. No meta-analysis is possible, does not allow specific conclusions. Somewhat frustrating, a bit disappointing. So, people like this are not happy with just talking about research to see what comes out. They want something more concrete. And I sympathise. Gregorovic and his colleagues talking about call were saying a question like this, does it work? It's a bit frustrating, and it is a bit frustrating, but politically it would be useful if we could answer it. And I think it is useful if we can answer a question, does it work? The answer won't be yes or no, it'll need nuancing, but we need to look at it anyway. So, the question then is, how can you measure outcomes? And this is the problem with a lot of research in applied linguistics, is that it focuses on probability. You know what it's like, you read a paper and it says, yay, there's a significant difference between the pre-test and the post-test, or the control group and the experimental group. And they've got statistically significant difference at the 95% level. Then you take a step back and you say, hold on, this paper, they tested the students, then they taught them for a whole semester, then tested them again. Of course there's going to be a statistically significant difference. How could there not be? And yet, after 15 weeks of teaching, they've increased their scores from 65 to 68. That's tiny. It's statistically significant, but it's not enough for me to want to invest in doing the same things with my students. Or, the other way around, you do a study, you get your results, you think, great, they look really good, but then you do your probability test and it says no statistically significant difference. So you think, God, if I'd had 5 more students with the same results, it would have been statistically significant. So probability is the statistics we do in applied linguistics are probability statistics, but they're flawed. And so you have, for example, the journal Language Learning, Nick Ellis's editor's statement in 2000. P-values are not acceptable indices of effect because they depend on sample size. Reporting of effect size is essential to good research. Submitting authors to this journal are therefore required to provide a measure of effect size. And an advantage is that an effect size enables readers to compare different studies, because an effect size doesn't depend on the number of students and so on. It's something which is independent. It's very simple to calculate. There it is. Cohen's d. All you need to know is the number of students, the mean score, and the standard deviation. So basically what you've got with Cohen's d is you've got the mean pre-test and post-test, or control group and experimental group, and it takes into account the pool standard deviation. So if there's very little variation, all the students are scoring very similarly, then you'll get a higher D than if you've got a lot of variation with students, some scoring 0, some scoring 100, and everything in the middle. Okay? That's the basic calculation. It really is simple, and any study, forget the statistics they do, if you have these descriptive figures, then you can calculate D. Sometimes you can extrapolate backwards. If they give you T values or F values, you can extrapolate from there. There are lots and lots of books about how to do meta-analyses. Another stage is wondering about if we can reduce some of the bias, especially if you have one study with 100 students, another study with 5 students, you might think, okay, maybe the one with 100 students needs to be weighted a bit higher. Hedges G, gives you an unbiased version of D. It takes into account the number of students involved. You do get some outliers, some really extreme results, so we Winsorized them at the 5th and 95th percentiles, which meant that anything which was above the 95th percentile, we just call it this score. So you wouldn't get a score of 50 standard deviations above the mean, which is just nonsensical. So we limited it 3, which was 95th percentile. So when you do it, so you can calculate an effect size for each individual study, and then you can put them all together. What is the result? Well, the result could be 0 or plus or minus. Now, normally you wouldn't get a negative effect size, a negative value for D, because it means that they scored lower in the post-test than in the pre-test. Or, you wouldn't normally get it. If you have a lot of studies, you'll find occasional ones that do give you a negative effect size. Or if you're comparing an experimental group with a control group, a control, of course, in our field doesn't mean 0 treatment. It's not a placebo like in medicine. They're having traditional teaching, traditional classes at the same time. So then you might find that your experiment doesn't work as well as a traditional format. So you could get a negative score there. But normally you don't, partly because of publication bias. Normally you'd have a positive number as a result of your effect size. Cohen, who gave his name to Cohen's D, was working in other fields. He recommended that 0.2 was an indication of a small effect size, 0.5 medium, 0.8 large. Why did he choose these figures? Because he looked at lots of studies and that's what seemed to be appropriate, which is not very scientific. But then you think of statistical significance. Why do we have P as 95%? Why not 96% or 94.37%? It's just, that's the figure we use. There's no more reason for that than there is for these. Oswald and Plonsky in the field of applied linguistics said that probably when they looked at lots of meta-analyses in our field, they said, well, we need to be a bit more conservative, perhaps because people are a bit fast and loose in applied linguistics or there's greater publication bias. They recommended that 0.4 would be considered small, 0.7 medium, and 1 large. Okay? So doing a meta-analysis in my field, or any field you choose, if we get 0.5, 0.7, we're quite happy. If we get 0.8 or 1, we're very happy. Okay? So, what did we get? Ta-da! More than 1! Hooray! That's the good news. But it's not finished. It's not the end of the story. Of course it's not the end of the story. You'll know The Hitchhiker's Guide to the Galaxy, many of you. An advanced civilization, thank you, wants to know the answer to the ultimate question of life, the universe, and everything. So they build a computer, and the computer spends 2 million years calculating. Then, when the computer has the result, this is what happens. The answer to the great question, yes, of life, the universe, and everything. Yes, is, 42. So it's the same here in a way, really. I mean, if your question is, how good is DDL, or does it work, and the answer is 1.19, you want something a bit more than that, really. Especially because there's a lot of variation. So a funnel plot, because it's supposed to be shaped like a funnel, on the y-axis you've got the number of people involved in the study, the number of participants. On the x-axis you've got the effect size. The red bar is the median, is the mean, with a confidence interval. So the confidence interval, 5% to 95% confidence intervals, we're fairly sure that the true mean should be somewhere in those levels. But you can see a lot of variation. There's a lot of variation here. And some negative scores as well. The question is how to account for the variation. Variation could come from two major sources. It could be a product of the study itself. Maybe it's the group size, like we saw in the previous one. Maybe it depends on the type of control or comparison group. Maybe it depends if it's a true or quasi-experimental context. Maybe it depends if it's a lab context or a classroom context, the duration of the study. Maybe you have a different effect size in studies which are published in prestigious journals compared to ones which are published in conference proceedings. Maybe it depends on the instruments used, how sensitive they are, the data analysis, all kinds of things that you could look at. Perhaps the biggest difference is within groups or between groups. Within groups is when you have one group, pre-test, post-test. Between groups is when you have experimental group and control group, as I mentioned before. If you look at within groups, so the same type of graph, y-axis, the number of participants, x-axis, effect size, the mean is 1.5. And it's fairly evenly scattered both sides. For the between groups, would you expect the mean to be higher or lower? This is pre-test and post-test. If you then compare experimental and control, you probably have a smaller mean. And indeed, 0.95. But 0.95 is almost large on Oswald and Plonsky's scale. So the sample sizes are bigger because you have two groups, by definition, in between groups test design. And the mean is slightly lower, that's to be expected. What's not to be expected is the difference in distribution. The within groups, it's fairly even throughout. The between groups, it's clustered on the left. It's partly the Windsorized ones and a few high scores lifting it up, but it doesn't look like it's quite even there. And that, we need to explore that a bit further. But apart from the study design, the questions that really interest us are the pedagogical ones. This is in line with Corson and Tilly's realist evaluation program. Their question is not what works or does this work, but rather what works for who, in what circumstances, in what respects, and how. It's the variation which is interesting. It's not the 1.19 which is interesting, it's the variation that's interesting. So the questions that would interest us is, does DDL, using the tools and techniques of corpus linguistics, have an effect for learners A in conditions B, working on language point C with tools and approach D for purposes E, compared to other learners, different conditions, different language points, and so on. That's where it gets really interesting. So the kind of moderator variables, once we've got our main effect size for the whole study, what we now need to do is to try to break it down and compare, for example, foreign language and second language context. Is there a difference there? If one gives a much higher score than the other, how can we account for the variation? This is the question. So we could look at the context and the learners. Age, maybe the people who do best with data-driven learning are people who are in their 20s. Or maybe it's teenagers. We want to know. Maybe women are better than men. Maybe it's a question of nationality as an indication of culture. Maybe it's more appropriate in Asian cultures than European cultures, or vice versa. Maybe it's a question of the L1 or the L2, foreign second language. Proficiency, maybe it's only appropriate for advanced learners. Maybe it's best for engineering students compared to humanities students. Are you using engcorpora tools as a reference resource, for example, for correcting writing, or is it really a learning tool? and the type of language data you use, the software, the interface, the activities, the language focus, all the rest of it. So these are all the kind of the interesting bits, and these are all the bits which we haven't done yet. So this is, as I said, work in progress. So I hope to be able to report on those things in a few months, but for the time being, I can't yet, I'm afraid. Partly because Tom Cobb and I, we're always travelling when the other one's available and vice versa. So, what we know for DDL is that we think it has quite good theoretical underpinnings. It corresponds to what we know about language and what we know about how we learn language. There is quite a lot of research, over 200 empirical studies so far. The research on the whole points in the right direction. Even if we modify the figure of 1.19 later on, it'll still be quite a large figure. It's not going to go down to 0.4. We do need more work to find out exactly where it works, who it's more effective for, in what conditions, etc. And always, the one thing that you should never say is that now we have a meta-analysis, we can stop doing research in this field. It's not the ultimate answer to DDL, all life, the universe and everything. One of the objectives of doing a meta-analysis is to see what research doesn't show yet, so you can see what more needs to be done. General lessons from doing an MA, so not specific just to data-driven learning. There is more research than you think. If you think you know everything, unless you've done it systematically, really gone out and collected it all, there's more than that you don't know about. Interpreting primary studies is not simple. There's a lot of room for subjectivity. And it's very annoying very often. That's something which really comes out from doing a meta-analysis when you're trying to, you've got a great study, but it misses out some really important information. It doesn't tell you the number of students involved. Or the number of students seems to vary in different parts of the paper. Why? How does this happen? Or what treatment did the control group have? What was going on exactly? There's so much that you realise when it comes to, because you don't just collect the studies and extract the data for the meta-analysis, you have to a very complex coding system as well. And all the squares that cells in the Excel sheet that have blanks in them is really quite disconcerting. If you're doing primary research, please make sure that you give all the information that somebody coming along and looking at your study should know, be able to know everything that's important. There are different types of syntheses, narrative syntheses and meta-analysis. Both are useful, both have their advantages, both have their disadvantages. You need to proceed with caution. In doing a meta-analysis or a narrative synthesis, there are a lot of choices. It's not just a question of going through the procedures and you get a result at the end. There are lots of things you have to decide. Exactly what calculations do you include? What are your inclusion criteria for the different studies, and so on and so on. And sometimes when you read a meta-analysis, people are not clear. A lot of things which we've realised are difficult, require decisions. When you read a meta-analysis, they don't mention them. And so you don't really know quite what's going on. It's a bit of a black box sometimes. So if you do a meta-analysis, there's a lot of choices, and when you interpret a meta-analysis, you may not know everything the researcher did. It does give us pointers for future work. It's not, the objective is not to come to an ultimate decision on something, an ultimate state of affairs. Everybody should do a meta-analysis. Tom Cobb provides a course in doing a meta-analysis in his research methodology classes in the master's degree in Canada, UCAM. And it's been a real learning experience. I shall never look at research the same way in future, having done this, even though I haven't finished it yet. It really does change the way you think about research and how you go about doing research. Everybody should do a meta-analysis. If you haven't, do one. And never ever do a meta-analysis. Because it is a lot of work. It really is. It's taken us a year and a half so far, and we're probably about halfway. Going back to the original paper by Norris and Ortega, a little comment at the end. We thank Craig Chaudron for prompting this research. We regret only that he failed to mention the enormity of such an undertaking. The enormity, of course, having looked to be nice and new. But anyway, I wouldn't have been able to do what we have done so far without Tom Cobb, and I hope, as I say, that one day we will finish and be able to publish something a bit more complete. Okay. Thank you very much.
Excellent paper. It really recalls many things. Many years ago, I used to do abstracts for language testing journal. I've never done such a thankless task in my life. Every paper was the same. There'd be a pre-test, a post-test, all the variation between groups. It was always the same thing. we have one group, the Benighted group, who are not subject to the fantastic new language teaching technique, the other group which is subject to it, and then we get a test which could be as little as 2 or 3 weeks later after they've done the thing.
Or 10 minutes later.
And it seems to me that, is this the claim for course linguistics, that somehow that we will enable you to cram more quickly and pass exams more quickly, or are we trying to make longer term claims about it? Are these the most appropriate tests for measuring the efficacy of data-driven learning? Perhaps you want people to carry with them their language knowledge through many years in life, not just pass an exam. Are there any papers going in that sort of, from your meta-analysis, anything going in that sort of direction, or is it all this control group, post-test, pre-test?
You've basically got the two designs. You've got pre-test, post-test, and you've got controlled experimental groups.
Mm-hmm.
Some of them are laboratory tests. They happen within the space of a single lesson. So those are the kind I've done them as well. They're interesting. Because a lot of people say, oh, you need lots of training to be able to use corpus data. But if students who've never come across a corpus before, if in 30 minutes they can work out a rule for something for themselves, or a pattern or a tendency, and apply that, then that's useful to know. So short-term studies are not without their interest. But I would agree with you, long-term is what's really interesting. I don't think long-term is interesting from the point of view of knowledge. Long-term is interesting from the way of thinking about language. If learners approach language differently because they've been exposed to a kind of approach where they work things out for themselves, they'll become more autonomous, more easily able to deal with authentic language, be more sophisticated in reasoning about language, be able to guess meanings in context, less disconcerted by that. Those are the important things. One of the things we need to look at is to see if there's a difference between short-term and long-term studies, certainly. So far, all we've done is we've compared the studies that have delayed post-tests. I haven't put them up there because I was only working on it until yesterday morning. And the results are actually a bit disappointing. If memory serves, the pre-test delayed test result was something like 1.3, so it was higher. But the control experimental delayed difference was something like 0.3. It was very low. I don't yet know why. I haven't yet found an explanation for it. Maybe it's not good. That's the obvious explanation. I'm looking for other things. I don't know what to say. But sometimes, if you have a teaching period which lasts 1 hour, pre-test, immediate post-test, and then the delay is a week later, I don't think it's really delayed post-test which is meaningful. I think it'll be the duration of the study which is more meaningful. And I haven't done that yet. But yes, I would agree with you. It's not the short-term outcomes. I think you can get benefits from data-driven learning immediately, but the best things which are really important are the long-term changes in behaviour and attitudes.
Strapping Michel Thomas to your head for,
But that's, of course, what's difficult to do, because the longer something goes on for, the more intervening variables come in. That's where you need to dynamic systems theory approach.
Research design.
But we do need more longitudinal studies, so please. Yes.
Thanks for this very nice talk, Alex. Just as a comment that you may find support for dismissing p-values from other disciplines. Only 1.5 months ago, one of the psychology journals actually banned non-significance hypothesis testing, and I found the relevant quote. Basically applies social psychology, will require strong descriptive statistics, including including effect sizes. We also encourage the presentation of frequency or distributional data when this is feasible, doing totally away with p-values, so something along your argumentation earlier.
I wouldn't necessarily say that p-values are a bad thing. For example, if you've got a medicine which increases your chance of not getting a nasty cancer by 1%, then, and a statistically significant difference, then 1%, who cares how it's potentially millions of lives which are saved. So even if something is statistically significant, even if the difference is small, it can still be useful. That's why in language learning, for example, they say it doesn't replace p-values, it complements it. You should have both. Yeah. And Cohen's d is not the only possible way of looking at effect size. If you give the raw data, basically you're looking at effect size. If you give a correlation coefficient, that's a form of effect size. But yeah, I think effect sizes are hugely underrated. Everybody panics, especially in France. In didactique in France, we tend to be much more qualitative than quantitative compared to Anglo-Saxon international norms. And most students tend to panic as soon as they see a number. But they shouldn't. Really shouldn't. Effect size is perhaps one of the most simple statistics you could possibly imagine.
Being French, I was wondering, at the end of your talk, what you're saying is that the work you have still in progress. Wouldn't you say that that part of your work is really a qualitative approach? The questions, that the parameters that you are putting forward are all of a sudden very defined.
It is and it isn't. Qualitative. I think quantitative research with no qualitative is meaningless. It's like the life of the universe and everything. You can look at variation. Because we're taking a meta-analytic approach, we'll be looking at quantities though. So for example, if you're comparing a short-term study under experimental conditions in a laboratory type condition compared to something which lasts 2 or 3 months in a classroom, then you've still got a number which you can attach to each. So we're thinking it's kind of halfway between quantitative and qualitative. But there will be a lot of interpretation. You need to be, this is one of the things which any introduction textbook to meta-analysis will say is don't just stay with the numbers. It needs interpreting. It needs qualifying. Otherwise people, because 2 reviews of my book chapter there which I mentioned, if I just had 1.19 in there, they come away saying, okay, it's great, it worked, 1.19. You can't stop there. You really have to go into it in a lot more detail. So yes, there's certainly a qualitative, but a kind of inside interpretation of what it means. Yeah.
Because you might find that the impact effect is stronger, is very strong for in some circumstances with some kinds of students and,
Yeah. It would be nice if we had a personality profile of all the students involved in these studies. Unfortunately, we don't. But we might find, for example, that we get higher results from Asian countries than from English as a second language environment, for example. Then the question is, what do we attribute that to? Maybe it's the researchers who are doing different things, or maybe it's the students who have different cultural profiles, different expectations about education, about language learning. So it'll still need interpreting. However far you go, you can always find grain of error. Yeah.
I have one question. As a chair, I grant myself the right to ask a question. So what we're saying here is basically being very careful when we use p-values, always try to correlate p-value with effect size, trying to blend qualitative and quantitative analysis. That's the kind of thing that either, hardcore corpus linguists or statisticians have been doing for the past 100 years, I would say. But you're talking about something that's crucial here, is that talking about an experiment with a desirable outcome. We're very lucky in corpus linguistics because we can do whatever experiment we like without any ethical issue or without any danger for the patients. Because you mentioned the case of medicine. When you test a new drug on the market, you cannot afford to distribute the drug to everyone around and see if there are people who die. Actually, we learned from the news that this is sometimes the way they do. So mathematicians have developed in the framework of causal analysis and causal inference, developed ways to get rid of p-values and effect sizes and try to predict the outcome based on a variety of variables, such as the ones you mentioned at some point in your study. And maybe, I don't know, since you have a very sound way of framing your statistical analysis, I think you can improve from that state-of-the-art work in causal inference in math. It's not really a question.
Yeah. Well, I think what we're doing can be dangerous. Thinking back to Mark Davies' paper this morning, if we go out and we describe language, say, okay, it's okay to use hopefully at the beginning of a sentence to say there is plus plural noun, and all of these things which don't correspond to the standard norm expected in journals. You might have a paper rejected, which could be life-changing for somebody. Could be, possibly. Or using corpora in forensic linguistics, but somebody could get life. Or get let off.
And forensic linguistics does not use p-values anymore. It's only quality.
I guess I'm assuming part of your motivation for looking for evidence for DDL is to convince teachers, classroom teachers. I don't know, is that a fair assumption?
Yes and no.
Yeah.
My students always, their initial question is they set out saying, I want to prove that this is better than this. I say to them, don't try to prove it, try to test it, try to find out. If I get results which say DDL is wonderful, I'm happy. But I'd rather know that it's bad, but know why it's bad. I'm not just trying to prove that. I'm trying to find out how, why, where, and when not. So there has to be the possibility of finding results which I don't like.
Okay.
Otherwise, it's not scientific.
Yes. No.
But if people do then think, because data-driven or using corpora is not something which is easy for many teachers, they will need suggestions that it's really useful before they're prepared to invest time in it. If it's only a bit moderately useful, they won't. But that's important to know. I wouldn't want to ask them to spend lots of time using something which isn't going to be very useful. So we need to know that.
No, I was thinking of the broader question of evidence in teaching and whether it's not a problem that there's no evidence. It interacts with teachers' judgments, teachers' approaches in the classroom. So even if you had the best evidence in the world, do you think teachers would still be convinced to take it up?
Have you heard of John Truscott? Who looks at corrective feedback?
Corrective feedback,
yes. Who in his position paper, it was sort of 1990 something, I think, was basically saying that teachers, one of the things that teachers do is they correct their students' language. No amount of evidence to the contrary will ever convince them that correcting written language is a bad thing. And he's right. I don't think the evidence does support what he's saying, but even if the evidence said correcting students' writing is a bad thing, teachers would carry on correcting students' writing. Teachers do what teachers do.